Thank you, everybody, for coming to this one. I know there's like at least 10 talks going on right now. They all seem really cool, so appreciate you coming to my talk. I'm going to get into Sorbet, which is a gradual static typing library for Ruby. You've probably heard of it. And specifically, I'm going to talk about how we use it at Grailed to just gain more confidence about the code that we're writing and shipping. First, just a little bit about me. My name's Jose Rosello. I live in Brooklyn. I'm a staff engineer at Grailed. And over the past couple of years, I've worked on infrastructure, security. Last thing I'm doing is payments, right? So I've just worn a couple of hats there. This is an overview of the talk and what I'll get into. I'll give you the context, just like where Grailed was and what finally motivated us to do static typing. I'm going to do a quick crash course of Sorbet, and I'll walk you through how we rolled it out at Grailed, and as well as some current issues or challenges that we face, and then leave you with some food for thought. So Grailed is a peer-to-peer marketplace. It's focused on style and fashion, mostly men's luxury goods. So basically think eBay, but if eBay were cool, that's Grailed. We have over 7 million users right now, and we use Rails almost exclusively to power our API. It's a large Rails monolith that has grown from 30,000 lines of code back in 2017 to around 150,000 lines today. Our developers were already somewhat familiar, or I would say pretty familiar with static typing and gradual typing through our front end, right? So we use TypeScript there. For that and for our Next.js code. The last line I have here, it's a bit of an exaggeration, but it truly was motivated by an engineer who was tired of shipping null pointer exceptions and subtle type issues, and so he figured this would be a good exploration, see if it solved those problems. So why static typing in Ruby to begin with? And I think the big thing for me here is feeling confident around refactoring and feeling confident, about the changes that you make, right? So Ruby being dynamically typed, let's say you want to refactor a method, maybe you get lucky and the method is like very uniquely named, and you like grep around the code and you find all of the instances that invoke your method and you change it and it's all good, right? But what if your method is called like new or call or some other name that's shared among a bunch of namespaces, right? You have to get really good at grepping. You have to really inspect the call site and understand what's happening. And I already sort of predict in the back of your heads, you're thinking, well, we have unit tests for these things, right? If I change a thing and forget to change it somewhere else, my test should break. But those are sort of, they're subject to humans, right? And they're subject to the quality of your unit tests. We love unit tests. We have a lot of good coverage, right? But you might miss things, right? You might have logic issues that you're not exploring in your unit tests. And a common example I can think of is we use Rails. We use Active Record a lot, and it's not unusual for you to just go deep and exploring sort of Active Record relations and making all sorts of assumptions about data being there or not being there, right? So that's an easy way for null pointers to sneak in and break your code. And I pasted just a bunch of PR titles, right? And I could probably fill like 10 slides worth of these, of type issues that we've fixed over the years. The other side of the coin here is around legibility and documentation, right? So the example I have here is using YardDoc, which is a standardized way of doing Ruby documentation, and we've used it in the past. It's nice. It provides a sort of a standard format for you to say, these are the types of my inputs, these are the types of my outputs, right? But at the end of the day, these are comments, right? And we as developers are not trained to look for the quality of our comments. If somebody comes and they refactor this to format method, they can easily forget to change the comment, and now we have stale and even worse, just misleading documentation, right? When I say better enforce documentation as a motivator, I'm coming from a place where Grailed is now, like I said, 150,000 lines worth of Ruby, and chances are that if you're working on any project of meaningful size, you're going to run into code that you've you've never seen before maybe, or you're just unfamiliar with, right? So seeing types there that you know are correct because they're checked by the type checker is just a great initial start. You know, you can at least get a sense of what the code is going to do. So I'm going to do a little crash course of Sorbet. And before I do, I mean, look, I know this is a Ruby conference, right? I know these things evoke a lot of strong feelings, right? People, you know, some people really hate type annotations or don't see the value. So before coming to this talk, I'm like, oh, well, you know, maybe there's some like evidence, there's some scientific research, right? Like that's a thing. I could maybe pull it up. And it, you know, it turns out the results here are fairly split, right? It's unclear whether the trade-offs of adding static types, you know, it being verbose and whatnot, actually is worthwhile. And what I'll say is that from what I've seen and read, a lot of the research is done on sort of toy code bases, a lot of times in languages that are older and may not offer the kind of strong guarantees that a modern type system can offer. So that being said, I'm going to get into Sorbet. If you hate strong types, please don't heckle me. Just enjoy the talk. So like I said, Sorbet is a gradual typing library. And what that means is that you sort of choose your own destiny here, and you get to pick the level of enforcement that you want. What it also means is that regardless of how big your code base is, you can get started with Sorbet almost right away because you can have sort of like the minimal level of enforcement. How Sorbet does this is through the concept that they call sigils. And these are magic comments that are declared at the top of your files. So enforcement happens at the file level. And I've outlined them here. I'll walk through them quickly. Ignore, Sorbet doesn't even look at this file. False, which is the default. So if you don't have a sigil, this is how Sorbet will treat your file. It just checks for syntax errors and missing constants. Then there's type true, which does everything that false does, but it also checks that the methods that you're invoking exist, and it checks that you're passing the right number of arguments, and if you have statically typed signatures in your file, it'll check those as well. Strict means that every single method and constant that you have in your file has to be statically declared. The types have to be statically declared. Strong is sort of like the ultimate level of this, and you know there's limited support for this because what this says is that any call that you're making within that file has to invoke code that is also typed, right? Sorbet itself has sort of limited support for this, and you know we don't really try to get to this level. So we aim to have true for existing files, and any new code that we write, we try to make it strict. Here's an example of a Sorbet signature, and if you've never seen, this is the first time you see a Sorbet signature, you probably think that this looks kind of hideous, right? If you've worked with other languages, usually type annotations are just a lot, they're elegant, right? And you can sort of read them off. So why is it like this, right? You may also notice that this is also valid Ruby code. And that turns out to be a pretty powerful thing. It means that you don't have to transpile this. There's no like 5-minute build time TypeScript kind of thing. And you can just kind of ship this code to production as this, right? This is valid Ruby. What it also allows Sorbet to do is to perform runtime checks. And I'll get into that in a second. But just, you know, so you see this example. There's a method called committed, and it returns a Boolean. We're telling it that, we're declaring that it returns a Boolean. Here's a bit of contrast between the two of the levels of typing, right? There's true on the left over here, and that's it's just normal Ruby code. All we know is that Sorbet is just ensuring that any constant or method that you're referencing there actually exists. And over on the right, we have a strictly typed one. We have declared every single constant, and we have declared the types for watermark as well. I'll point out just a funny syntax there. It's pretty self-explanatory, but like, you know, photographers, for example, we're saying this is a hash that takes in symbol as keys and returns string as values, for example. And let me go back to runtime checks, right? I think this is really, really important, I think, especially for gradual typing systems, right? Because what you end up running into, by definition, is you'll have code that is untyped, and then you'll have code that is typed, And the code that is untyped will inevitably invoke the code that is typed. Now, statically, Sorbet can't tell you anything about this, right? Your untyped code can pass the wrong parameters, right, the wrong types to your typed code, and it won't know any better, right? But it does know at runtime. If Sorbet sees that the wrong types are being passed to your type method at runtime, it by default raises an exception and says, hey, this is not the type that I expected. At Grailed, we don't treat these things as exceptions, so you can customize this behavior, right? And we don't treat it as an exception because a lot of times what we've observed is that these types of errors usually happen when you're adding types retroactively to old code, right? And so you as a developer, this is your best effort, let's try to type this old code, you make a mistake, and you don't want to punish yourself, you don't want to punish yourself in production for that, right? So by not treating them as an exception, we don't do it. But what we do is we alert ourselves through a Slack channel, So we've added types to some old code. We get a Slack alert that says, hey, this code that you have typed is receiving the wrong inputs, and then we can go and correct it. So this is a win-win for us, right? We've learned a lot about our code, we've added types in the process, and we never broke production. So I've been talking about typing your own code, and that's awesome, that's great, right? But what about your dependencies? What about code that is not actually written in text, right? Dynamic code. Sorbet's answer to these things is the RBI, or the Ruby interface file. And all an RBI is declarations of classes and methods and constants. And I'll show you an example soon, but it's essentially a skeleton of code. There's no actual body in these things, right? And in the case of gems, Sorbet will inspect your gem code, and it will generate these code skeletons that basically have the same declarations that it can find in your gems. And it's not obvious why that is, right? Why can't Sorbet just inspect the gems themselves? Why does it need to sort of make these separate definitions, right? These skeletons. And there's two good reasons that I know of, right? One, Sorbet aims to be really, really fast. It is really, really fast. And having it inspect the entire body of your gems will probably slow it down. And the second one is more practical, right? If Sorbet detects a type error or an issue in your gems, you're not left with much of a choice there. You have to go and edit the gem code or fix some type definition in your gem. So it's not really all that practical. And the RBI is its answer to that, right? Let me walk you through an example for this one. So this is pry. This is a debugger that you're probably all familiar with. And this is what Sorbet has generated after inspecting your gems, right? Here's sort of the overall structure of the class, and here's some methods, right? And it doesn't know anything about the types, right? This is the best that it can do. It knows that there's methods. It knows that there's some arguments that you have to pass. But that's the best it can do when generating these things, right? There we go. And this method is a little more, this RBI is a little more interesting. So this designer here is actually an active record model that we use. And this was generated by a gem called Sorbet Rails, which I'll mention a little later. But it's a similar idea. It inspects your active record models, and it generates the signatures for dynamically declared methods. And what you'll notice in this case is that there's actually type signatures, so it was able to figure it out. And it can do so because Active Record already knows about these types, right? It's already doing that work, translating your database columns to Ruby types. So the generator, it can be smarter about it. So as part of the crash course, I'm gonna just go through Sorbet's, what I think are its greatest hits, our favorite features. This is T-nillable. If you've worked with the maybe or option type in other languages, this is pretty self-explanatory. It basically ensures that you can't, you're not able to call a method that potentially doesn't belong to your object, right? So in this case, on the left, we have this label nillable string that we're passing along. We're calling upcase, which is a string method, and Sorbet understands that this could be nil. So you shouldn't be able to call upcase. That's going to be a type error, right? But over on the right, we have it within this if check. And if the code that, if you reach the code that happens to be in the statement, you already know that this label is actually a string, and Sorbet is flow sensitive that way. It understands that now it can only be a string, so this is a legitimate thing to do. And it leverages that sort of flow sensitive behavior to perform exhaustiveness checking as well. And there's a little bit of code going on here, but I'll do my best to walk you through it. And by the way, this is all fake. This is not like real Grailed code, just in case you're wondering. But this phi here on the right is an enum. Again, if you've seen them in other languages, it's just defining a limited set of values, right? So phi here can be none, it can be a standard phi, it can be a new member phi. And over on the left, we have a method that's receiving this phi, and it wants to do different things depending on what the value of phi is, right? Now you'll see that absurd, the T absurd line there at the bottom, and what that's telling Sorbet is that if that line is reachable code, we have a type issue. So what that means is that as it is now, when we're checking all of the values that phi could take, this is unreachable, so this type checks. But if I were to remove phi.none or phi none, this would raise the type error. And where the value here is, if you're working with an enum and you're adding a new possibility to it, and it's very, very important that the callers understand how to handle these things separately, it means that if we add a new phi here, you would have to go and handle the various call sites, right? So we use this a lot for payments errors, where it's really important that we handle all the possibilities, usually in different ways. So adding a new error means having to go to the call sites, and the type checker is letting us know, hey, there's some unhandled possibility here. This is tstruct. This is a utility class that ships with Sorbet. And all it is a data vessel that you have to declare fields and types for. And optionally, you can make these fields immutable. And this is awesome. I mean, we have used this to refactor a bunch of APIs that previously used hashes. Hashes, there's all sorts of defensive coding that you have to come up with. Does the value exist? Is the type that I expect, right? Whereas here, it's very clear what kind of data you're working with. And it's also, self-documenting, right? So this is definitely something we've been using a lot. One of the more unfortunate things about the Ruby language, in my opinion, is that of implicit returns. It can lead to some very succinct code. It looks very nice, but it also leads to a lot of accidents. You may accidentally change the return of your function, or you may just be returning a thing that you don't want anybody else to see. And what this void return type does is prevent that entirely, right? So this is documenting that this method, send messages here, is only important because of its side effects. It doesn't matter what it returns. We don't even care, right? And on top of that, Sorbet actually ensures that the return value of this method is actually overridden at runtime. It returns a special void object. So even if you wanted to use it, you can't. You have this. The caller has to basically. It would be a type error, right? You'd have to interact with this like void object. That doesn't really make sense. Let me walk you through the rollout process. The initial steps are actually quite easy. There's a couple of utilities that Sorbet ships with, and the first step is just generating the RBIs that I mentioned earlier for your gems. You can start running the checks almost right away, and you'll notice that a bunch of things break. For us, we had some dynamic imports all over the code. Sorbet didn't like that. It actually immediately found undefined constants from like dead code, so the value was just already jumping at us from the first day. And Rails being sort of like such a dynamic magic framework, it had a lot of issues with that as well. And there's answers though. We figured out. So Sorbet Rails is a gem that basically helps you overcome a lot of these Rails challenges, and it creates RBIs for all the dynamic methods that Rails generates for you, especially in our case for active record models. I mentioned that Sorbet has tooling to generate RBIs for your gems. However, we've used Tapioca, which is a Shopify tool. It's a similar purpose, but we find it friendlier to work with and just easier to customize in general. If you use RubyConf, the Ruby linter, there's an add-on for that we enjoy. It helps us enforce that sigils are declared on top of files. And sort of in concert with that, there's another tool by Shopify called Spoon that allows you to auto-bump the strictness of a file if it knows that there's no issues, right? So it can go from false to true if it knows that that's not going to cause any typing issues. It also has some reporting facilities as well, which I'll actually show you next slide. But once you have your initial steps and your initial setup out of the way, the big thing for us was evangelizing Sorbet, talking to people, and just eventually getting to the point where we could enforce it, right? So thankfully for us, everybody was very curious and sort of, I think a lot of us just like types in general and like working in a strongly typed environment. So, people asked questions, we had a couple of presentations, and a few weeks went by, and we eventually just decided, hey, we might as well just start enforcing this on CI now that we're down to 0 errors. And if people run into issues, tell them to reach out to us. And if it goes really badly, we'll just revert and not do this. But thankfully, it never got to that. And people really started adopting Sorbet and started typing their code fairly proactively. And the stats I have here are generated by the Spoon tool I mentioned. And the sigils graph is basically, the headline there is that only 8% of our code files remain type false. And 70% of the calls that we make are invoking code that is typed. So we've come a long way. We still have a long way to go, though. That's where we are today. This is sort of a more advanced example, but I'm sure everybody has some kind of dynamic code that they've used themselves, or they sort of created for their own code base. And this is an example from ours that we had to sort of figure out, right? But we have these concepts of service objects around our code, and if you haven't heard of these, it's usually just the idea that you want to encapsulate any sort of complex business logic or things that usually have side effects, right? And the protocol that we use, the interface that we use for these things is just having an initializer, take some params, and then there's a single public method called call, and that's that, right? And because it's usually invoked as in, service object.new.call, it's a kind of boilerplate, right? And so we like to just have this helper here on the right that we included to just be able to call a service object with a class method call instead. Pretty harmless, right? But of course, Sorbet absolutely hates this, right? This is some dynamic thing. We don't have types. How can it possibly know? At first, we were thinking, hey, maybe, we really like Sorbet. We want to type our service objects. Maybe we can just do this manually, right? Maybe we can have this like redeclare self.call every service object, copy and paste the same parameters from initialize over, blah, blah, blah. I mean, this is awful. This is entering Java territory, right? So we wanted to sort of avoid this entirely, and I've sort of hinted at how Sorbet likes to approach these things, right? You want to make some RBI. You want a tool to be able to generate the RBIs for you. As humans, we know what to do. We know that we just have to take the parameters from our initialize, right, and sort of declare this like new class method call that takes in those parameters and returns whatever the instance method call returns, right? And so after looking into it, it turns out the tooling is not that complicated. We used a library called Parlour, which is what Sorbet Rails actually uses under the hood to generate its own RBIs. And the code here is surprisingly legible, I think. All this is doing is going through the source code of our service objects. It's inspecting to see if there's an initialize method declared, if there's a call method declared. And if it does find them, it'll create an RBI that has the class method call with the input parameters that initialize takes and with the return type that the call instance method does, right? So we package this thing into a rake task, and we run it, and suddenly we have RBIs for all of our service objects with our our helper self.call method, right? Very cool, very powerful. Like I said, we had to remove a bunch of dynamic imports. We used a library called dry monads before, which is honestly probably worth another like 30, it's like another 30-minute talk just to talk about that library. So I'm not gonna get into it too much, but it clashed a lot with Sorbet, and we found ourselves not needing it as much. You know, we had sought out something to get stronger guarantees in our code, and we were using this dry monads library, and it turned out that we were able to basically replace all of it, more or less, with constructs from Sorbet. And this is an example. If you're not familiar with the result monad, it's basically a vessel that either has the value that you're interested in or some sort of error, and I'm really simplifying it. But the idea here from this example is that we have an error type, and I'm introducing a little bit of new syntax there. It's an alias that the error type could be either an invalid permissions error or a no listing error. And then the function below returns either a listing, which is what we're interested in, or one of the error types, right? And over on the right, the caller is now forced to inspect that, you know, am I getting back a listing or am I getting back some kind of error type, right? And where this shines, right, versus having just like a begin rescue block is in places where you really want the caller to deal with the consequences of an error, right? And I hate to use payments code as an example twice, but it's all I've been looking at the past month. And we use it there for similar reasons, right? There are some errors that we really need to handle in a specific way. And this makes sure that the responsibility is here very clearly documented for the callers. I crammed all of our challenges here, and it makes it look way worse than it is. But you know, I've talked a lot about RBIs and these utilities and like generating these things, and it's kind of a pain. You know, we haven't figured out a solution around like automating some of these things. We have at least 3 rig tasks that we have to occasionally run to make sure that our types haven't fallen out of sync. And you know, we've kind of learned to live with it, but we certainly don't love it. I talked a lot about runtime checks, and I think it'd be great to have it actually be enforced one day, but we're really, we don't feel like we're anywhere close, especially as we continue to gradually type code. This is not something that we want to pursue. You know, ultimately, an issue with gradual typing is that things will slip, right? You might become really confident and think like, hey, like, clearly this code makes sense because the type checker hasn't said anything, right? But you may forget that there might be some untyped code in there, and it's not actually doing what you think it's doing. Sorbet lets you inspect things, and you can see what kind of types are being returned. You can integrate this kind of functionality with your editor, right? So it helps, but you may miss it, right? RSpec is its own beast. If you use RSpec, basically I recommend that you ignore it entirely. Type information is kind of limited in these tests anyway, so we just basically ignore it. Rails is very dynamic, right? I think there's a big impedance mismatch that you have to fight to get it to work. And Sorbet Rails does an incredible job at facilitating this, but you'll still run into issues. I think some Rails concerns are still unsupported, for example. So you'll run into issues there. And you know, a lot of developers, a lot of experienced Rubyists are, you know, unfamiliar with types or don't like types, right? So it's going to be a learning curve, and it's going to be an adjustment period for people picking this up for the first time. And the last thing I'll say here is that Sorbet is very much a work in progress. It's very much a beta product. New versions will break your existing code all the time, usually for the right reasons, sometimes for arbitrary reasons, right? But you are going to run into issues and into limitations, and you have to proactively work through this. I'll conclude this by saying that I think after 2 years of Sorbet, we're still really invested in it. We really think it's provided a lot of value, and the team really enjoys working with it. And it's met our goals. You know, the parts of the code that are typed just can't run into the class of issues that I mentioned earlier. And finally, we're hiring. You know, I'm contractually obligated to read this. I'm just kidding, but we have grown a lot the past year. We've doubled in size. We expect that trend to continue. And even though it's a high growth environment, we have excellent work-life balance, great benefits, compensation. We're also fully remote, although we do have an office in New York. And the talent team suggested that I speak from the heart when narrating this slide. So I'll speak from the heart. I think, honestly, this has been the best employer of my career. I've been here for 5 years, and there's a reason for it. And I'd love to see you there. If you're interested, go to grailed.com/jobs, reach out to me. We also have a booth out here. So come talk to us. Here's some light reading. If you want to read research papers on static typing, you can go to sleep reading these. Thank you so much for coming. I'm going to hang out. If you have any questions, just come talk to me. I'll be here. Thanks so much.